Hello everyone, in this exercise of the Solidworks, we will create a summary of a scissor lift table. Let's start. File, new, part, this one. This is the Solidworks user interface. I am selecting the background plain white, unit system is the millimeter ground second. Okay, I am taking front plane. First, I will create a platform for this. Center rectangle, this one, and smart dimension, this I am taking 120 mm. Okay, this one, and this dimension I am taking 65 mm. This is 55 mm. Okay. And sheet metal base flange, I am taking dimension 2 mm, but I am taking in the reverse direction. Okay. And this one rectangular sheet, there is no need of the auto relief in this case. Base flange, now edge flange, I am taking this and this. This dimension I am taking 20 mm. 20 mm material from outer virtual shaft and the band metal inside. If you see left, metal is inside. Metal is inside and the height is from this point. Outer virtual shaft means outer edges intersection point. This point to up to this side. 20 mm length, outer virtual shaft and this one. Angle 90 degree, inside radius 2 mm. Inside the band radius is 2 mm. If you check, this is 2 mm inside. How I will check this thing? Evaluate, measure. This radius is, you will check 2 mm. Radius 2 mm. And height is this one, and this height and this height. This is 20 mm. This delta jet. Okay. And this distance from this to this is 65. Okay. Sheet metal isometric, this one in this way. I am selecting this face, selecting this face, sketch, and will create slot and hole here. Smart dimension, this dimension I am taking 3 mm. 3 mm radius. And this dimension I am taking 50 mm. And this to this I am taking 6 mm. Okay. This point I will create a circle here. Circle dimension is 6 mm. And this distance is 6 mm. 6 mm distance, 6 mm 50 mm distance. But sketch is not fully defined. Line you take from this point to midpoint, this one. Select another line from this point to this midpoint. Select this point, horizontal, this point, horizontal. Sketch fully defined. Okay. Now sheet metal, extrude cut, sheet metal, extrude cut. This is through. I am giving the appearance, this one from here, and this appearance is I am taking this color, light. Save it. This is the first part. First part is the name is the platform. Platform. Okay, save it. Now find another part. Newer part, this one. background plain white, and unit system millimeter gram per second. Redefine front plane, sketch. I am taking line first. I will draw 3 circles. This is actually arm. Select this, shift this, and this. These are equal. Dimension is 6 mm. Okay, and this dimension I am taking 90 mm. Okay. Now again we will draw 3 circle more. This one. Again select this circle, shift this circle and this circle. These are equal. Pull down. This one, and this is, I am taking this die is the 9. Okay. Draw 2 lines. Horizontal. Make sure this should be horizontal. Another line. Horizontal. Okay. Now select this line, shift and inside circle. Any inside circle, tangent relation. This one. Again select this line, shift and inside circle. Any inside circle, tangent. Okay. Now select this point, shift this point, coincident relation. Select this point, coincident relation. Select this point, coincident relation. Okay. Select this point, coincident relation. This sketch is fully defined. Now, future extrude boss base. There I will not trim anything. I will select in selected contour this one, this one, and this one, whole thing in outside, and this one, and this is whole selected. I am not taking anything, but in direction 1 I am taking this as a thickness of this arm. I am taking 2 mm. Okay. Color, you can give it color. This one, appearance, give it color this one. Okay. Here, and second part is the R. Okay. This one. Now, file, new part. This one. Background plain white. Unit system millimeter, front plane, sketch. This third part, this is the rod. This is I am taking 6 mm. This is the rod. And future extrude boss. This dimension I am taking 65 plus 4 plus 4. This is the as per assembly. I am taking this dimension. This dimension you will check. This is the 73. Save it. This appearance. This copy. This one. This you can take it green color. Okay. And this one. And save it. Rod. Third part is the rod. Now pin. next part, last part. This is the rod. Background, plain white, unit system millimeter. This one, this circle. This is 6 mm. 6 mm. This length is future extrude. This length is only 4 mm. And color of this I am taking. I have made 4 parts. Let's save it. This is the pin, not pin. Now I start the assembly. File, new, part, assembly. This one. First is the platform. This one. I am taking this one. I will rotate X, Y, Z axis. X is this one. I am rotating about X axis in this way. I am not clicking in the graphic area. Go in the view header tool and click this one. And again, click on this I button. This click on this star. And the item is the fully defined component. Okay. Now again go in this and uncheck it. This part is the fixed. First part in the assembly always remains fixed. If you want to float it, but I want to keep it fixed. And the background is the plain white. Okay. Now I bring another component. Assembly, another insert component. I am bringing rod. First I am bringing rod. This one. You can rotate it as per your requirement. You can about X, Y, Z. But I am not. This one. Made, relation, made, and from here first important relation made is mechanical. Slot made, select this and select this one. This one. Okay, and hit the right button. This slot made will force the rod between this slot only. It will not move beyond this slot. Okay, and also it is rotating on x-axis. Okay, in this way. Now advancement, go advancement with me. This mat, I will place this rod at the center of this thing, between this point, between two surfaces. First select this face, and tab section, this face, and this way. Now hit OK button. Now rod is at the center, at the middle. Okay. Again, you can bring another component. Insert component rod. And this and this concentric relation. Okay. Now advancement, width map. This face and this face, and tab section, this face and this face. Now rod is at the center of this thing. Okay, hit OK button, right button, cancel. Now this one. Now I will bring another component. For another copy of this part, select this part, control, press and hold, and left mouse button and this one. Drag. This is another copy. Now insert component, gain rod. Click. Mat. This part, mechanical mat. First slot, this part, and any surface, this slot, anywhere surface. This is the slot mate, and then hit this button, again advanced button, advanced width map, this face and this face. Okay, and tab section, this one, and again this section, this surface. Now hit right button. Now it will be at the center of this. Okay. Now again insert component, rod, this one, mat, this one, this and this. Concentric relation. Okay. Okay. Now again advance width map, this face and this face. Now tab section, in the tab section, this face and this face. This face. Now it will be center. Hit right button, okay, and cancel it. Now bring another part. R. This is the R. You can rotate as per your requirement, but there is no need of this one. This one. I will move in this way, cross in this way. Now, mat this hole and this one. This one. What is the concentric relation? And now this one, this surface and this surface. This is the coincidence relation. Okay. I will move in this way, cross way. Now, this face and this concentric relation. This is concentric. Now again this face and this face. Coincidence relation. This part is this. Okay. This. Okay. Now cancel it, insert another component, that is the R. Okay. Now mat this inside circle and this outer circle. This is the concentric. Okay. And another mat, this surface and this surface. But this is not coincidence. I will keep it at a distance of certain. I will tell you how. 2-1. This is at a distance of 2-1. Now this inside circle and this inside circle. Concentric relation. Now this circle and this concentric relation. Okay, cancel it. In this way, I have fixed on one side. This way. Okay, and this one. Later on, we will fix the distances. And now, again, in this side, this side. We have to move cross in this way. Insert component R. This one. Mat. In this way, we will first this one and scissor. Concentric relation. Okay. This one, this face and this face. Coincidence relation. Okay. This part, this side, and this. Concentric relation. Okay. Now, of this part, insert component. First, insert component R. Now, mat this and this. Concentric relation. But this surface and this surface. Coincidence, not coincidence, but maintain distance of 2 mm. Later on, I will tell you. This one. This one and this one. This is the concentric relation. Okay. And this one, this and this. Concentric relation. Okay. Now, this. Now another part, one last part. Insert component, pin. This. Now mat this and this. Concentric relation. Okay, this face and this face. Coincident relation. This in this way. In the same way, insert component, pin. Mat this one. First is this one and this one, this face. This one, concentrically, and this face and this face. This face and this face. This is the coincident relation. I have fit all the part. Okay, this. But this is moving beyond this one. I will fix a limit. This is maximum distance. Okay. First, I will check the distance. What is the distance? Evaluate, measure from this face to this face. What is the distance? That is the 71.16. This distance is this from this and flange and face and this one, that is 71. So I will make a limit for this. Okay. How? Mat assembly, mat advancement. This is the advancement. Minimum distance I am taking 1 mm and maximum I am taking 71. I have noted. I will keep it 70 mm. And face this one. this face and this face. And hit OK button. So if you see, this is the minimum and maximum 70. In this way we have fixed this. This way we have made a assembly of a scissor lift table assembly. We have fixed the distance of this one. This is 1 mm and this is the 70 mm. In this way, we can add more component at the bottom, etc. and for the refinement of this product. So I hope you would have enjoyed this exercise. You please like, share, and please subscribe my this channel to grow up to a great extent. Thank you for watching. Thank you very much.